So, integration, as we know, is the opposite of differentiation. Now we're going to use factors here. Difference of two squares on top, take out a 2 on the bottom, and what we should have here is anybody get x minus 4 over 2, otherwise known as x over 2 minus 4 over 2, otherwise known as x over 2 minus 2. Is that alright? Now we're integrating from 1 to 0, x over 2 minus 2 dx. Now we've got to remember it's the opposite of differentiation. So we're going to add on a power, and we're going to divide by the new power. So it's x squared over 2, but now we have to divide by the new power, which will put another 2 on the bottom. Would everybody be happy with x squared minus 4, x squared over 4? If I differentiate that, what will I get? If I differentiate x squared, what will I get? 2x over 4, which changes back into x over 2. I can check if I'm correct, okay? What happens to the minus 2? What happens to minus 2? Just add on an x. And now we're at the stage where we've integrated it properly. Now we have these two limits here, which is 1 and 0. So what are we going to do here? Sub 1 and 0 in. So 1 squared over 4 minus 2 times 1. Take away zeros because x is in everything. And what do we get? A quarter minus 2, which is minus 1 and? We got minus 1 3/4. There we go. Happy days. Alright. So I move on. Alright. Now, 22 part 2. Alright. Go to your tables and look up what happens when you integrate sine. What happens when you integrate sine? What does it tell you in your tables? Plus cos or minus cos? Huh? Thank you, minus cos. So it's minus cos 3x. The angle never changes. The function will change, but the angle will never change. Now I have to figure out what else do I have to put in. You assess the angle and you differentiate it. And what you get when you differentiate it? Huh? You get 3. So you put a division by 3 underneath. If you were to differentiate that, it will turn back into sine 3x. In fact, it will turn into minus sine 3x, and then you differentiate the angle to get 3. And then you have the 3 underneath that cancels it, and then you end up back at sine 3x. Okay? Now, we're going to put in our limits. Now, please remember that cos 0 is actually has a value, okay? So the zeros won't just disappear this time. Now, if x is pi over 6, what's 3x? 3 pi over 6, which is pi over 2. Is that alright? So what we're going to do here, we're going to have minus cos, replace x with pi over 6, and you get 3 pi over 6 divided by 3, minus cos 0 over 3. Now, to my knowledge, cos 90 is 0. That's cos 90 degrees. Enter into your calculator, you get 0. And what's cos 0? Cos 0 is 1. What's minus a third? Plus a third. We cool with that? Okay. Anything else from question 22? Okay. 19, 22, 23 parts 2 and 4. Is that right? 2 and 4. Okay, let's try this part here. Okay. What's the rule for exponentials, Connell? What happens when you either differentiate them or integrate them? What always stays the same? Alright, you know the power stays the same. Perfect. What do you have to divide by then? Differentiate the power and divide by the derivative. So what's the derivative of the power? What's the derivative of 1x plus 3? No, not the integral, the derivative. Differentiation. When you differentiate x, you just drop the x. So if I differentiate 7x, the answer is 7. Differentiate 1x, the answer is 1. Differentiate any number? Gone. So we didn't even have to put in the 1, did we? Nope. Alright, now we're at the stage it's from 1 to minus 1. Now what you do now? Lob them in. What happens when e is 1? It's going to be e to the power of 4. What happens when it's minus 1? E to the power 2. And your answer is e4 minus e2. You can write it like this if you want. Or you could throw it all as decimals. Does anybody have the answer in decimals? Did anybody get that answer? Yeah. Is that what it has in the back of the book, presented like that, is it? Is it? That's lazy. Soft. Now, 47.21. You want to go for that? Questions? Yes?
So when you're integrating e to the power of x plus 3, do you differentiate?
Now, integrate e to the minus 2x plus 1 dx. Alright, Gaffigan. What happens when you integrate e to any power? Grand. So you know straight away e to the minus 2x, don't you? Now, what do I have to do with this if I'm integrating? Differentiate the power. Now, is it plus 2x or minus 2x? Huh? So when you differentiate it, you put it over minus 2. What happens when you integrate 1? No, that would be, if you differentiate 1, you get 0. Yeah, good man. 1x, okay? And then you have this from, I forgot the numbers, didn't I? 1 to 0, is that okay? What happens if you divide anything, what happens if you do 1 divided by minus 2? What is that? That right, Brian? Oh, it's minus a half, isn't it? Yeah. Now, okay, what you get next? What you plug in next, Connor? Oh dear.
Well,
What you plug?
one.
What?
First you plug in 1.
1. Yeah. And then the other part?
Plug in 8, take that away from 0.
So 0, yeah. Minus 1 e to the power of 0 over 2 plus 0. Alright. Now, what is e to the power of 0? Just 1, isn't it? So it's almost like it's not there. And then, so what's 1 take away a half? A half, isn't it? And what's that? That's minus a half e to the power minus 2, isn't it? You could lob it all into the calculator and get it in decimals. Is that the way the back of the book did it? Or did it present it in terms of e? What? This plus 1 here? I already used it. Oh, sorry. 2 minuses makes a plus, so it's 1.5. Thank you. So we pay him the big money. It's 1 plus a half, which is 1.5, which is 3 over 2. Is that the way the back of the book has it put down? Yeah, I know what they did now. Alright, get this. 1 over, what can I do with this power here? What is e to the minus 2? 1 over e squared. So it's 1 over 2e squared, is that right? And that's plus 3 over 2. What can I factorise out both these? I can take out a half, and what's left over? Minus 1 over e squared plus, that's meant to be a 3. Is that okay? Alright, tough going there. Okay, split the fraction. So it's e to the x over 2 plus e to the minus x over 2 dx. Integrate. E to the x stays the same, it's still e to the x. The derivative of the power is, what's the derivative of the power? 1, so there's no change. What's the, once again, this one doesn't change either, but what's the derivative of the power, Connor? So what you do with the minus 1? Underneath. So that minus 1 multiplies by the 2 to turn it into minus 2. Just go and adjust this really quickly. So you should get e to the x over 2 minus e to the minus x over 2. It's 1 over minus 2 again. And the two numbers you're talking about are 2 and minus 2. Right? Plot them in, you get e squared over 2. And that's going to be minus e minus 2 over 2. Then replace all x's with minus 2's. And then minus minus 2 will be plus 2. Now, does anything cancel here? So, did anybody get e squared over 2 minus e minus 2 over 2 minus e minus 2 over 2 plus e2 over 2. Two of them are, so what's a half plus a half? So what's a half e squared plus a half e squared? E squared. What's minus a half minus a half? Minus 1. What's minus a half? E minus 2 by another half e minus 2. Just minus e minus 2. And your answer could probably look something like this. Alright? Anybody get that far? Did you just leave it like that? Yeah, alright. If you go onto your log tables onto the integration section, will you do that for me now? Log tables on the integration section. Okay? Now, do any of you see a to the x anywhere? And what does it say for the integral of a to the x? A to the x and? Yeah, that's all you gotta do. So, therefore, what's the integral of 5x, 5 to the power of x? Five to the power of x over ln 5 from 3 to 1. And what do we get here then? We get 5 to the power of 3 all over ln 5 minus 5 to the power of 1 all over ln 5. You can lob that into your calculator if you want, or some of you may have written it like this. What can I factorize out top and bottom? Once if I take out 1 over ln 5, what's left over? Would everybody agree 5 to the power of 3 minus 5? Okay. And what is 5 to the power 3 minus 5? What's 125 take away 5? So 120 over ln 5. Is that cool with you? Alright. Do question part 4 now on your own. The same deal. Should be handy. Yeah. 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 La, 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 la. And the upper power is e. So the integral of e, 0 to e, ln x dx. The integral of a to the power of x is a to the power of x over ln a. So what do you reckon, Oscar? What's the integral of 7 to the power of x?
7 to the power of x over 2, 1.
No, ln 7. The a value is 7. It's whatever number it's getting power to is, whatever number is the base number is the a value. Okay, now you have e and 0. So what are you going to do now, Connor? Or sorry, Oscar?
Put in the e to the x.
Minus
7 to the power 0 over ln 7.
What is 7 to the power of 0?
0. 1.
1. Alright? And they both have the same denominator, don't they? I can have it like that, or I can have it presented like this. Whichever one takes your fancy. All good? Alright, 26 for the road. Yes.
Just why do you put in the
Why?
Yeah.
It's just, we looked up on page 26 and it was a preset rule. Now we actually proved it in the last exercise. Remember the question I had to do like 3 times? It was on, I'll show you now. Okay. We shall blank this part off. Doesn't exist. Alright, Charlie, you know what you're doing? U is x, yeah? What's the u dx?
1.
What's phi?
Sine 3x.
And when you differentiate sine 3x?
3 cos 3x.
We're doing the product rule, so it's u to v dx plus phi to u dx. Okay. And so we're going to get x times 3 cos 3x. And then v times 1. Alright, which is 3x cos 3x plus sine 3x. Everybody cool with that? Right, now here comes the next part of the question. I'll just scroll this up. There you go. Hence, evaluate this. Now, here's what we're left with, okay? This is our answer for the derivative. So this here is our answer for the derivative of dy dx. Okay? I'm going to cross multiply up the dx. So it appears here, and it also appears here. Is that alright? Now, what's the next thing I'm going to do? I'm going to integrate. We're going to integrate both sides. But the limits have to be the same on every one. If I'm integrating them, I should probably integrate them the same. Is that okay? Now, this is where things get slightly awkward, alright? Slightly awkward. See those limits? What value are they for? Are they for x or for y? Read the question. Dx, and there's your limits for an x function. So what's the issue here? Yeah, it's currently dy, isn't it? So we're going to figure a way around that. Alright, what's the goal of the question? The goal of the question is to get this thing on its own. Would that make sense? So everything else needs to go to the other side, doesn't it? Alright. So here's what we're going to do instead. What was the original y? It was x sine. Everybody see it was x sine 3x? Okay. So here's what we're going to do. We'll integrate y anyway. Okay? And when we integrate dy, what do we get? Y. Now the problem is I can't use y with these numbers. But what is y? It says at the very start of the question. Y is x sine 3x. So we're actually doing x sine 3x pi over 6 and 0. Then we have equals our yellow friend here, the guy that we Alright guys. Alright guys, now what we're going to do next is we're going to integrate sine 3x. And what happens when you integrate sine? What you get? Is it plus cos or minus cos? Minus cos 3x. Differentiate the angle. We got a 3 underneath, don't we? And what are the two ones? It's pi over 6 and 0. Is that alright with you guys? Now, yeah. So we're at the stage where we can integrate these. Now, if I'm in an exam and I'm feeling slightly lazy, not really trusting where my head is at with the calculator, I have a little trick I often use when I'm doing these limits. Okay, and I'll show you the trick now. Okay, so here's my trick. As I said, I don't like straining myself more than I have to. Okay, so here's what we're going to do. I'm going to start off with, see x sine 3x, everybody? See that? Here's what I'm going to do. I'm going to go to my table function, the greatest invention ever in a calculator. I'm going to put down x sine 3x. Now, I also need to make sure my calculator is in degrees or radians. You alright with radians? Okay. What two inputs do I need? I need 0 and no bother. Start 0, end pi divided by 6. Step pi divided by 6. I'm only going to get two answers now, am I? 0 and pi over 6. Look at this. There's my two answers. 0 is 0 and pi over 6 is point. Huh? Yeah, that can happen. That can happen. Let's find out, does it happen? Yeah. The input and the output are the same. Let's find out. Okay. So, you'll see now. X is pi over 6, isn't it? X is pi over 6, yeah? And what's 3 times pi over 6? Pi over 2. What's sine pi over 2 or sine 90? Huh? Is it 1? It's 1, is it? X sine 3x. Is it 1? Alright, cool. Sorry about time there, lads. Finish off tonight and I'll do it fresh tomorrow. Tell you what, study for your test, okay?